In this video, we're going to talk about arithmetic sequences, what they are and how we calculate their formulas. So we're going to start. I'm going to ask you to take a look at the 8 sequences listed here, and I want you to figure out what their pattern is. And it says in the question that 5 out of the following 8 sequences are something that we call arithmetic. It looks like the word arithmetic. In this case, I tend to pronounce it arithmetic. What I want you to do is to pause the video, take a look, and see if you can figure out which 5 of these are the ones that are arithmetic. Hopefully you paused the video and you actually tried it. I'm going to zoom in a little here. What I did was I took a look at the sequences and I figured out what the patterns were. So for the first one, we were adding 1 each time. In the second one, we were adding 10 each time. In the third one, we were multiplying by 2. The fourth one, we were subtracting 5. The fifth one, we were adding 2. The sixth one, we were dividing by 2. The seventh one, we were adding 25. And in the last one, we were going up by kind of 10. So 10, 20, 30, 40, 50, 60. So out of these 8, 5 of them are something we call arithmetic. So you want to try to see if you can figure out ones that are the same. I notice one that involves multiplying, one that involves dividing, one where the pattern's a little different, and I notice there are 5 questions where we are either adding or subtracting by the exact same number. So I would say that the first one, the second one, the fourth one, this one here, the fifth one, and the seventh one are all arithmetic. And an arithmetic sequence is a sequence where you're adding the same number every time to get the next term. So there is a place for definition down here. If I zoom back out, it says an arithmetic sequence is a sequence where you're adding something we call a common difference. So it's the same number you're either adding or subtracting by every time. So I'm going to say where you add or subtract. The same number each time. I'm also going to write in here that that same number is something called a common difference. Common because it's the same, and difference because that's what happens when you subtract two things, right? You're looking at the difference in between them. So we're going to start by looking at just arithmetic sequences today. So previously we've done recursive formulas and explicit formulas. We looked at some slightly different patterns, some where you're multiplying, some where you're adding, some where you're doing weird things. But in this case today, we are only looking at ones where we're going to add and subtract the same number each time. So we're going to take a look at an example here that says we want to write a recursive formula and an explicit formula for the sequence 5, 9, 13, 17, 21, and 25. So the first thing you should always do whenever you're looking at a sequence is try to figure out what the pattern is. So I'm looking at 5, 9, 13, 17, 21, and 25. And if nothing immediately jumps out at you, take out your calculator and try some things. So if I'm trying to find the pattern, I'll usually take the second number and then either add or subtract, multiply or divide to see what I can get to turn it into a 5. So in this case, I'm going to try doing 9 take away 5, which is 4. So to get from 5 to 9, I've added 4. If I try doing 13 take away 9, I've also added 4. And if I check, 13 plus 4 is 17. 17 plus 4 is 21. And 21 plus 4 is 25. So definitely see a pattern here where we're adding 4 each time, which actually makes it an arithmetic sequence because we're adding the same number every time we're adding 4. So we've talked about recursive formulas and explicit formulas. A recursive formula is a formula where you use the term that came before the one you're looking at to calculate the next term. And an explicit formula is where you can just put in the term number you're looking for, like n, and calculate the term that you want. So we're going to start with the recursive formula since that's what we learned how to do in the previous video. To find the recursive formula, what I'm going to do is start by just listing out the terms, and I'm going to call them term 1, term 2, term 3, term 4, term 5, and term 6. Now I know that term 1 is 5, term 2 is 9, term 3 is 13, term 4 is 17, term 5 is 21, and term 6 is 25. And what I want to do is I want to look at how I came up with these numbers. So the first number 5, I actually have no idea where that first number came from. It's just the number where we've started our pattern. But the next number, the 9, I know that I got that by taking 5 and adding 4 to it. To get the 13, we took 9 and added 4 to it. To get the 17, we took 13 and added 4 to it. To get that 21, we took 17 and added 4 to that. And to get the 25, we took 21 and added 4 to that. Now, if I take a look at term 2, this 5 is really term 1. So I can say that this is the same thing as term 1, which is 5 plus 4. Okay, for the next one, for term 3, 9 is really term 2. So it's term 2 plus 4. 13 is really term 3, and we added 4. 17 was term 4 plus 4. And then this 21 was term 5 plus 4. So what I want to try to do is create a recursive formula by extending this pattern to figure out what term n would be. So if I was looking for the nth term, how would I find the nth term? Well, I know that term 6 was term 5 plus 4, and term 5 was term 4 plus 4, and term 4 is term 3 plus 4. So I notice that every time I am definitely adding 4, and I'm always adding 4 to the number that came before the term that I want. So if I had term 6, I took 1 away from 6 to get 5. So if I have n, the term that came before n would be term n minus 1. So to calculate any term in our sequence, we would say term n, or say term 10, is term n minus 1, or 10 minus 1, which would be term 9 plus 4. Now this works for every single term here except for the very first one, and I don't really know where that came from. So we say that this formula works for everything except for term 1. So I say where term 1 equals 5. And that is the recursive formula for this sequence. Now to find the explicit formula, we're going to do something a little bit different. We're actually going to go back to these pink numbers, and we're going to try to think about where some of these numbers came from. So if I had 5 plus 4, I'm actually going to leave that alone. I'm going to say it's 5 plus 4. Now, if I take my 9 here, how did I get that 9? This 9 came from doing 5 plus 4. So I'm going to say that this was 5 plus 4, and then there's this plus 4 on the end here, right? So 9 was really 5 plus 4, and then plus 4. Okay, 13 is the same thing as 9 plus 4 or 5 plus 4 plus 4. So I'm going to do 13 plus 4. Okay, 13 is the same thing as 5 plus 4 plus 4. If I come down to the next one, we did term 4 plus 4. My term 4 is really 5 plus 4 plus 4 plus 4. So I'm going to put that in. It's a lot of 4s. And then for the last one, it's term 5 plus 4. Term 5 is really 5 plus 4 plus 4 plus 4 plus 4. So if I take a look at this, that's a lot of 4s. So I'm going to try to find a slightly easier way to write this where I don't have quite as many 4s that I have to write down. I notice in the last one there are 1, 2, 3, 4, 5 4s. So I've got 5 plus I have 5 4s. So instead of writing 4 out 5 times, I can just put 5 times 4, or I have 5 4s. For the next one up, I have 1, 2, 3, 4 4s. So I have 5, that's the first part, plus, and then I have 4 4s. Now in this one, I have 5 plus 1, 2, 3 4s. Okay, this one here we have 5 plus 2 4s. This is 5 plus just 1 4. I could leave it like this, but we're trying to generate a pattern here. And then the very first term was just a 5 with absolutely no 4s whatsoever. So it was 5 plus 0 4s. Now, if I wanted to figure out the nth term here, and I wanted to figure out what Tn was, I noticed that all of these had a 5. So I'm going to write 5. And then I noticed that this number is a little bit different, so we'll come back to that. And then I noticed that all of these are 4s. So the question is, where did this number come from? Where did the 0 come from, or the 1, or the 2, 3, 4, 5? Well, if I take a look here, I'm doing term 6, and this number here is a 5. In term 5, we have a 4. In term 4, we have a 3. In term 3, we have a 2. In term 2, we have a 1. And in term 1, we have a 0. So it's always one smaller than the number that's here. So if I was doing term 7, I would go one lower and use a 6. So if I'm doing term n, I need one number lower, which is going to be n minus 1. Now I can leave the formula like that, but I would actually multiply the 4 into the bracket to get 4n minus 4, and then simplify this a little to get that Tn is 4n. Now 5 minus 4 is 1. So Tn equals 4n plus 1. Now that works for all the terms. It works for the first term. It works for the last term. So I don't have to put in where a T1 equals some number. Now there is a shortcut, not for finding the recursive formula, but for finding the explicit, I should write that down, that's explicit. For finding the explicit formula, there is actually a little bit of a shortcut and a formula that we can use. And it's just for arithmetic sequences. It doesn't work for other sequences.